It's time for bed, turn down the light. So let's clean up and say goodnight. Good night, fire truck, good night, plane. Good night, dump truck, good night, train. Good night, bus, and even bigger, best of all, say good night, digger. Okay, folks, so that song is from a book called Goodnight Digger, and I just went ahead and I wrote some music to the words in the book because Henry liked it so much. And what's fun is that you can actually sing the thing that I did in the intro for any part of the book. So there's another part here. It goes, good night trailers, good night rockets, good night cars stuffed in your pockets. That's fun. Not at all what we're discussing today. I just kind of wanted to share. So let's get started. Okay, so what I really wanted to talk about today was a game that I created for Henry called Saami. And as usual, I'm going to walk through a video of him and I playing it together. And this video is pretty typical of what like your average session would look like, right? So let's take a look.
I want you to do.
A red one.
Yeah.
Does it like the red?
Papa.
Saami malinki.
I'm asking him Saami malinki, which is the smallest or which is the least. Saami is a superlative, right? That can mean either the most or the least, depending on context.
Papa, hard one.
This is a hard one. Saami malinki.
Well,
There you go.
A red one.
Saami bolshoi. No. What number is that? They're all.
so you'll see him clicking all of the 8s, right? And so that's some insight into how the game actually works. All of the cards are the same value except for one of them, right? And in the first 2 scenes, he clicked the card that was different from the rest, either the biggest or the smallest. But what we're seeing here is every single one of the other cards is exactly the same. And he usually does the first 2 or 3 correctly and then starts clicking the cards that are wrong because he likes seeing them kind of fly away. And this is kind of a design flaw that this is a mistake I've made in the past where I make the failure animation more exciting than the success animation. When you succeed, you go to the next one and sometimes it's a different color, but he really likes like pressing the cards and watching them go away. And so I was going to fix this, but then I noticed something else. Here, watch.
8s. Saami bolshoi. There you go.
He waited to click all of the ones that were wrong before clicking the final one. And you might say, well, maybe that was unintentional. He actually does this, and it took me the longest time because I'm always like, hey, no, you're doing the wrong thing, to stop and realize, oh, he's clicking every single one that's wrong. So he actually plays it in 2 different ways. Sometimes he'll press the one that's different from the rest so he can get to the next color, and the other times he'll press all of the wrong ones, right? So he can watch them go away, right? And as of right now, he doesn't have any concept about the score or anything like that. He's just interested in the interactivity. Okay, so I talked about this game in episode 1, but I wanted to revisit it because it's important to understand why I developed the Saami game and why it's so good for younger kids. This might look simple. He's only matching 2s and 3s and 1s, and I created this level specifically for him. But I was actually surprised. Even though I know this is a difficult task for younger kids, I was actually surprised at how challenging it was for him. Let's watch just a little bit.
Can you find a match? There's a 2. Can you find another 2? Maybe a red 2?
So coaching him a little bit helps, but for the most part, he finds this a very difficult task, and this is definitely like, I don't know, the 5th or 6th time we've played this. But it shouldn't be surprising at all that kids would struggle a whole lot more, particularly younger kids, with precise counting than they would estimation. And then in the next segment, I'm going to go into a little bit more of why that is from a cognitive psychology perspective. I'm going to provide some examples and then also some readings that you can do on this specifically. But it's just really important to call out that doing precise counting, games like this, and also estimation tasks together is really, really important, because what you might find starting to work with a younger kid is a little bit of counting, 1, 2s, 3s, realize they're not really getting it. They can look at a 2 and say that it's a 3, or they can go 1, 2, 3, 10, just for fun. So a lot of times you can be working with a younger kid and think they don't really know anything, but it's not because they don't. It's because you're not unlocking their inner mathematical superpower. And it's a superpower that we all have called the approximate number system. And it's an innate sense of approximate number that allows us to do quick computations with relative quantities. Kids already have it, and they're already really good about it, and they're actually already really quantitatively curious. And that's where the Saami game came in, is that I wanted to exploit this sense that kids have of approximate number and give them a space where it can be celebrated. So what is the approximate number system? A great place to sort of see and feel the approximate number system in real life is a place called Panamath.org that actually has an approximate number sense calculator. And this is part of a very large research experiment that has had some interesting results over the years, such as, is there a relationship between the approximate number sense of your average person and the approximate number sense of someone who has, say, a PhD in mathematics? The interesting result is yes, right? But it's not quite as much as you would think, right? The approximate number sense tends to be something that is innate in most people. And even if you have absolutely no formal training in precise counting, right, your approximate number sense is still fairly well developed and on par, if you're an adult, with the rest of the population, with some variation, but it's not nearly as much as you might think. And that's really, really interesting. If you can give someone no mathematical training whatsoever, and they already have this sense of approximate number, which is correlated to mathematical ability, that means that young kids, right, come with this approximate sense of number baked in. And so that's why it's so interesting for me on a personal level, looking into this research and saying, how can it unlock opportunities for parents and their kids to work together? As I mentioned in the previous segment, very, very frequently it can be hard to work with young kids on mathematics just because you're not doing the type of mathematics that comes natural to them. Dang! Okay, so let's play this really quick. In order to do the demo, you just have to enter your age. So I am 28 years old, and begin. All right, more yellow, more blue, more yellow, more blue, yellow? No. So what I want to point out here is that it's not hard to do this quickly, and more importantly, it's not uncomfortable to do this quickly, right? Putting a timer on an activity like this doesn't really make the activity that much harder, right? Because our brains like to do these type of computations quickly. They are evolutionarily designed to do approximate numbers quickly. That's the whole idea behind approximate number sense. And there's an interesting study where they show people 2 digits, and people have to determine which digit is larger than the other. Right? Now, you would think there's just single digits. People's time answering these shouldn't vary too much based on what the digits are. But what they find is that if the numbers are far apart, say 1 and 9, you take slightly less time to respond than if the numbers are close together, 2 and 3, or the relative size of the number is close together, like 8 and 9 would take someone a slightly bit more time longer to identify than the difference between like 7 and 9 or 6 and 9. And so the way I interpret that, right, is that our brains are doing an estimation or an evaluation of the quantity before our conscious mind does it. So if I flash these images to you, you're probably evaluating which is more and which is less before you have the time to consciously think which is more or which is less, right? Your brain does it before I even ask the question, right? Or before it consciously thinks of which one's larger and which one's smaller, right? Just sort of my interpretation of it, but I encourage you, read some of the research. I'm going to link a bunch of stuff below. There's awesome books about this. I'll link this site as well. Go check it out. If you've got kids, have the kids play it too. I haven't done it with Henry yet. It's on my list. All right, so before I go, let's play together a little bit. We just did the approximate number sense calculator. Let's go ahead and try the Saami game and see how the first couple levels shake out. So pretty simple, pretty far apart the numbers, not too much trouble. Played a lot of these before. Ooh, I like this level. Here we go. Now I got some symbols. These are a little bit harder than you would think. You got to be careful with these. There's 4, right? And then here are the actual symbolic numbers. So what you'll notice here is that I've folded in symbolic cards as well as cards that get closer and closer and closer to each other, right? So the approximate number sense game is good for approximate number sense specifically, right? But the reason I created this game was to sort of build on that and say, okay, like if we can initially appeal to kids' sense of approximate number and then slowly push them towards the symbolic precise arithmetic, right? It's a whole lot easier of a progression than it would be just starting with counting and cardinality from the very beginning, right? So thanks so much for watching. This has been a fairly long video. I almost cut out some of the stuff I did about the approximate number system, but to be honest, either you're interested in it or you're not. So if you tuned out for that part of the video and somehow made it here, thanks a bunch. I encourage you to go back, watch it a little bit closer, or just click on some of the research that I listed already. Oh yeah, and thanks for watching the intro and listening to that silly little song. I actually also did a version of Baby Shark that I... Oh no. Shark. Yep, here it is. Baby Shark. Baby Shark. Baby Shark. Mama Shark. Mama Shark. Mama Shark. Mama Shark.